Hello, this is Robert Raussendorf speaking from the University of British Columbia in Vancouver. This pitch is about the theoretical foundations of quantum computation, contextuality, Wigner function negativity, and beyond. A question that we investigate in my group is what makes quantum computation work? Or what is the quintessential resource in quantum computation? In this regard, we have recently studied contextuality and Wigner function negativity, and are now transitioning to something different but related that we do not yet have a good name for. And so the topic of this pitch is quasi-probability functions in quantum computation. The simplest quasi-probability function is the Wigner function. It is like a probability distribution over classical phase space, except that it can go negative. This negativity is seen as an indicator of quantumness, and in quantum computation, one can make this intuition rigorous. Namely, Wigner function negativity is a necessary precondition for the speedup in quantum computation. This was first shown by the Emerson group for qubits in odd dimension, and subsequently generalized to other settings. A recent counterpoint is that if one generalizes the Wigner function slightly, the need for negativity disappears entirely from the states and from the operations. And if so, then what makes quantum computation hard? What you see in the current slide is the playing field for this pitch. The basic research question is, how far can we push the classical simulation of quantum computation? The impact that we expect this research to have is, first, improved classical simulation techniques for quantum computation, and second, a better fundamental understanding of the quantum speedup. This is our team. There is Michael Zorel and myself at the University of British Columbia, and our external collaborator, Jian Okai. Maybe a few words about myself as the PI. My business card contains two essential items. First, the one-way quantum computer, and second, fault-tolerant quantum computation in 2 dimensions. Now over to you. What we are looking for is expertise in discrete math, such as graph theory and convex optimization. Also, we look for expertise with seq-POVMs, specifically the number-theoretic aspects thereof. Finally, we look for expertise in foundations of quantum mechanics and quantum logic. Interested? Then please contact us.